Dear students, today's topic P chart and NP chart, which comes under the topic variations of attributes. Formula for P chart. P chart is nothing but fractional defective chart. So formulas are you have to find three control limits: UCL, LCL, CL. So for UCL the formula is P bar plus 3 into root of P bar into 1 minus P bar by N. For LCL, instead of plus put minus. For control limit, P bar equal to number of defectives by capital N into number of items. Next, for NP chart is nothing but number of defectives chart. So the formula for upper control limit is, you can use this formula or this formula. So use this one, this is easier. NP bar plus 3 into square root of NP bar into 1 minus P bar. Similarly for LCL, formula is NP bar minus 3 into square root of NP bar into 1 minus P bar. So let's see an example problem. The data given below are the number of defectives in 10 samples of 100 items each. Construct the P chart and NP chart and comment on the result. So roll number 1 to 10 is given, number of defective is given. Solution. Let P denote the number of defects. So first calculate P bar, that is control limit. Formula is number of defects by capital N into number of items. Here number of items given is 100 items each. So N equal to 100. Number of samples is denoted by capital N, which is 1, 2, etc. 10. So capital N is 10. Therefore P bar is equal to number of defects, means add the number of defects, 5 plus 12 plus 6 plus 6 etc. So that will be 58 divided by 10 into 100. So our answer 0.058. So that is control limit P bar equal to 0.058. So next we find the other control limits, that is UCL and LCL for P chart. So write the UCL formula, P bar plus 3 into root of P bar into 1 minus P bar by N. So substitute the corresponding values and simplify it. You will get the answer as UCL equal to 0.127. Similarly, LCL is P bar minus 3 square root of P bar into 1 minus P bar by N. So you just subtract the value and the answer is minus 0.011. If the LCL is positive, you can take that value. But if LCL is negative, then you should round off the value to 0. That is, you have to take LCL value as 0 if it is negative. Next, we draw the P chart. X-axis, you have to take the number of samples, 1, 2, 3, 4, etc. 10. In Y-axis, you have to take the fractional defective. Since the P chart definition is fractional defective chart, you have to divide the number of defectives by number of items. So you have to divide by 100. 5 by 100, 0.05. 12 by 100, 0.12, like that. Divide all these values by 100 and take those values as y-axis. You have to take the values in the y-axis, 0.02, 0.04, like that. Now draw the UCL line, CL line and LCL line. LCL is 0, so this is your LCL line. Plot the points. How will you plot? 1, 5. If you divide 5 by 100, 0.05. So 1, 0.05. If you divide 12 by 100, 0.12. So 2, 0.12, like that. Similarly other points. So check all the point lies between UCL and LCL. If all the point lies between UCL and LCL, the process is in control. Otherwise, the process is not in control. Next, control limits for NP chart. Control limit. Formula NP bar. We have already calculated P bar as 0.058. So N is total number of items 100. So 100 into 0.058 is 5.8. Then for upper control limit, formula is np bar plus 3 into square root of np bar into 1 minus p bar. Substitute the values and the answer is upper control limit is equal to 12.82. Next, lower control limit np bar minus 3 square root of np bar into 1 minus p bar. So substitute and the answer is minus 1.2. I already told that if LCL is negative, take LCL as 0. Now we draw the NP chart. X axis 1 to 10. In Y axis you have to take the defective values because NP chart is number of defectives. So you can take the actual values itself, number of defective. So you can give it as you can give it in the 10 difference, or here we have written as 2 difference, 0, 2, 4, 6, 8, 10, 12. Draw the UCL line, CL line and LCL line. If all the point lies between UCL and LCL, the process is in control. If it is not, the process is not controlled. So we found in this problem, both in P chart and NP chart, all the point lies between UCL and LCL. So the process is in control. Thank you.